We might have an answer to a cosmic conundrum that's been bothering astronomers for quite a while. The cosmological principle states that on large scales, the universe should appear the same in all directions and from any location. That is, it's isotropic and homogeneous. However, on smaller scales, we know this breaks down. The fact that you're reading this and watching this means that the Earth is here, we have a solar system, and there are stars and galaxies, which means that on those much smaller scales, the universe doesn't look the same everywhere. Some cosmologists think that the difference between the large scale and smaller scale universes may be responsible for the discrepancy we see between the value for the Hubble constant, as measured from the cosmic microwave background, compared to the value we get when we look at the local universe closer to us. Just a reminder, the Hubble constant is basically a way of expressing the expansion rate of the universe. These astronomers believe our galaxy might be in a local void in space, an area with about 20% lower density than the average of the universe. One tricky thing with this idea is that it turns out to be quite hard to prove that you're in a void like this, and some astronomers reject the whole idea. In a recent paper published in the monthly notices of the Royal Astronomical Society, a research group has shown that it's actually more likely than not that such a void does exist in the universe. They determined this by looking at baryon acoustic oscillations in the early universe. These are acoustic waves in the primordial plasma just after the Big Bang, which are the seeds of structure formation in the universe. These oscillations are frozen into the cosmic microwave background, and by studying them, we can predict what the large-scale features of the universe will end up looking like. The research shows that models with a void are much more likely than models without one at 3.8 sigma. Taking this into account, our local universe would be expanding about 10% faster than the distant universe, and the values we get for the expansion rate at different scales would come into agreement. There's a lot more work to be done on this, but it does seem to offer a plausible explanation for an enduring conflict in observational cosmology. That's today's video. Please drop a like and subscribe before you leave, and I will see you in the next one. Cool news from Mars today, where research suggests the many glaciers on the red planet's mountains are composed of 80% or more pure water ice. I have no idea when humans will set foot on Mars, given the pace of progress on getting the issues with Starship figured out, not to mention science budgets being slashed left and right, but I'm sure we'll get there eventually, and having a plentiful supply of water will be a huge factor in determining the habitability of the planet. Water's heavy, and having to launch your own up on the long journey to the red planet is going to be a major pain. Of course, previous research has detected and measured these glaciers, but there's been wide disagreement about what the actual water content is. Are they mostly dust and rock with a thin layer of water ice, or mostly water ice with a thin smear of rocks on top? The new study uses the SHARAD shallow radar instrument on board the Mars Reconnaissance Orbiter to determine that the glaciers are indeed mostly water ice with a thin debris layer on top. You can see the sites that were surveyed in this image. The composition of these glaciers is consistent between the northern and southern hemispheres of Mars, suggesting they were probably formed by the same mechanism. Exactly what that mechanism may be is still open to debate. They could have formed when snow fell in the past and led to the formation of glaciers, or they may have formed by a process called direct condensation, where layers of frost form on the surface of the planet and eventually create the glaciers. Much more work to be done here investigating other glaciers on Mars and trying to get a better picture of how they formed. But at least we know there's plenty of water, and that's super useful information for the future exploration of Mars. I dropped a link to the paper in the description. That's today's video. Please drop a like and subscribe, and I will see you back here in the next one. We talked about Mars earlier in the week. Now it's the Moon's turn for some new research that might affect future exploration and settlement of our natural satellite. You may think of the Moon as a dead rock, but that's not quite right. Scientists have looked at rockfall and landslides at the landing site of the Apollo 17 mission in the Taurus-Littrow Valley to see what they can learn about earthquakes on the Moon, called moonquakes. They discovered evidence for repeated moonquakes over the past 90 million years along a fault line called the Lee-Lincoln Fault that crosses the Taurus-Littrow Valley floor. This is just one of thousands of similar thrust faults on the Moon that seem to be still active. Thrust faults are thought to be caused as the Moon cools down and parts of its crust are forced together and upwards. Tidal forces from the Earth may also contribute to the movement of the crust. Although the moonquakes caused when the crust moves are relatively weak, only magnitude 3.0 or so, they could still pose a risk of damage to future lunar outposts that are located close to them. The researchers note that the risk of a damaging event is relatively low at only 1 in 20 million per day. That's probably not a big deal if, like Apollo 17, you're on the lunar surface for 22 hours. But if you build a lunar outpost to last a decade, the probability of a damaging event would drop to 1 in 5,500. Given that it should be possible to avoid building in areas with faults altogether, this will be just one more factor for mission planners to take into account when deciding the best place to locate a long-term moon base. Currently, the next planned mission to put humans on the moon is Artemis 3, scheduled for 2027, although I wouldn't be surprised to see that schedule slip. The paper was published July 30th in the journal Science Advances, and as always, I will drop a link in the description. That's today's video. Please drop a like and subscribe before you leave if you enjoy the content, and I will see you in the next one.